Hello friends, I Dr. Rajendra Babar from Sinhagan Institute of Technology, Lonavala. Today I'll be giving the expert talk on digital electronics. So हम देखेंगे कि digital electronics why it is important as compared to the analog electronics. So both the things are very important, analog things as well as digital things, as we come across a number of times about the analog signals. But the problem with the associated with the analog signals is that one can't store the value, or if it is possible, it is in terms of fractional values. It requires more memory. So that's why we need to convert each and everything into digital electronics. Digital electronics stores the value in terms of zeros and ones only. So it is possible to combine the signals to form the word and form the letters and numbers also, and it is easier to transmit the zeros and ones through the wires. It easily one can transmit from one end to the another end. Also it is possible to store the things, so memory requirement is less in case of this digital electronics. So everywhere the government also requests us move into the digital era, and this digital era is nothing but what? Converting everything into digital electronics. We shall see in the upcoming things, that is what are the different applications of this digital electronics. And communication also happening digital way. So all the traditional traditional phones are being replaced with the mobiles because of the digital communication only. So entire analog communication, while transmitting the signal from one end to the another end, the conversion is from analog signals waves into converted into high and low levels. So that means zeros and ones, and it forms the signal. So for now I am talking, that means it is analog signal is being generated from the microphones, and while transmitting from one end to the another end, the digitally it is being converted into digital. So it is very easily to mux doing the combining the digits, numbers, zeros and ones, and transmitting from one end to the another end. So multiplexing is possible at the transmitting end, and at the receiving end the demultiplexing of the signal is there. And also encoding and decoding concept is there in the digital communication. That is, encoding means if 16 bits are there for any information transmission, so one can combine it in encode it into the 4 bits only, and while receiving, it receives 4 bits and decoded into the 16 bits. So in this way it is possible to merge to, one can say, the increase the channel capacity in this. So while downloading or implementing anything, it may be the embedded system application. So take the coffee vending machine, take the washing machine, or traffic light controller or lift controller. So things are embedded. So microcontroller is being used, and how the microcontroller is being used, depending upon the commands given by the user, it actually functions. So user gives the commands in terms of zeros and ones only, and digitally the machine is being operated. So while doing the programming, in any case of programming, so everything is converted into digital. That is the one thing. Another section of implementation is the VLSI. So in VLSI, the application specific integrated kind of thing is there, CPLD is there, FPGA is there, then system on chip is there, reconfigurable computing is also there, fault tolerance is there. For everything we are in need of digital signal. So in digital electronics is a vast area, and this is the prerequisite for all kinds of embedded system, VLSI subjects, and industry need also. The digital electronic subject is very important. In communication also it is being used. So initially the logic family is important. In logic family it operates basically on the TTL and CMOS. So TTL is nothing but the transistor logic, and CMOS is nothing but complementary metal oxide semiconductor. The difference among these two kinds of transistors, the transistor logic is having faster, that is the base characteristic, it is faster, but its a drawback is it is having more power dissipation. But in case of the CMOS, CMOS is slower, its delays more, that's why it is operated in a slower way, but its power dissipation is less. So depending upon the application, whether you want a speed or you want a less power dissipation, one can choose the TTL category or the CMOS category. So in this way, one can construct the basic gates. So basic gates, everyone knows, in case of diploma, degree or industries also, the NAND gate, NOR gate and AND gates are there. So these are the gates. With the help of those gates, one can construct any kind of thing in digital. Okay, so this is the requirement for this. So for digital electronics, for studying, we are in need of three things. One is the symbol, logic symbol. Second thing is the truth table, and third one is its expression. So depending upon these three, one can construct any kind of digital circuitry. While performing the practical also, we come across the multiplexer, demultiplexer, encoder, decoder, then counters and registers. So flip-flops, base for these counters and register is the flip-flops, and there are many types of flip-flops are there, that is JK flip-flop, and it is being developed by the Jack and Kilby. Then D flip-flop is there, T flip-flop, that is toggle flip-flop, RS flip-flop is there, that is a reset and set flip-flop is there. So each category is having its some advantages and disadvantages based on the requirement or application they are being used. Or it is possible also to convert one form of flip-flop into another form of flip-flop. There is a procedure. Along with the truth table, we are in need of the excitation table. So with the help of this truth table and excitation table, we can convert the one flip-flop to the another flip-flop. Then counters. So it may be a synchronous or asynchronous counters are there. Synchronous counters are nothing but they are operated with the same clock. That means three flip-flops are there. So single clock is with the help of single clock, one can operate all three flip-flops. They will be triggered, they will be operated at a single time. Single clock is possible. That's why it is called as a synchronous counter. An asynchronous counter is nothing but it is also called as a ripple kind of counter. The output of the first flip-flop acts as input to the second flip-flop, then second flip-flop output acts as input to the third flip-flop. That's why it is called as a ripple, or one can say a synchronous counter. And these counters are being constructed either by the T flip-flop or JK flip-flop, because they are having the toggle state. JK flip-flop and T flip-flop itself name suggests that it is a toggle flip-flop. And toggle, if we check the truth table of the counter, always the rightmost side in the truth table changes from 0 to 1 and 1 to 0. So that's why we are in need of the toggle flip-flop or JK flip-flops first and last condition, that is 0 0 and 1 1. 1 1 is there, then JK flip-flop toggles. Toggle means changes when it receives one clock, it changes its state from 0 to 1 and 1 to 0. So that is the reason why T flip-flop and JK flip-flop is being used to construct the counters. But one can't use these same flip-flops to construct the D flip-flop. उसका रीजन है D flip-flop wants output same to that of the input. So transference, delay, or this is called as a delay flip-flop. D flip-flop is there. So output is same to that of the input as it is. So that's why a register is being constructed using D flip-flops. D flip-flop, group of D flip-flop is called as a register, and group of register is called as a memory. So in case of memory, what we need? In memory, we are in need of storing the data, users data as it is. We don't want to alter the data. So इसका मतलब है, if anyone store 0, 0 should be stored. Suppose anyone want to store 1, 1 should be stored. So in this way, the combination of 0 and 1s should be stored in the memories. So memory, many kinds of memory are there. It depends on the requirement, one can use the memories. Then coming to the next application, that is in case of VLSI, FPGA, CPLD, the last thing, it begins with the PLA and PLA. So it is nothing but the PLD, programmable logic devices. So programmable logic devices are generated because of the, if we go for the any kind of digital circuit IC, those if I take an example of 7400, it is a NAND gate. It can't work for the mux, demux, or half adder, full adder. That's why these ICs are called as a fixed function ICs. One can't use for the other applications. They will do their dedicated task only. इसका मतलब है कि हम दूसरे काम के लिए यूज नहीं कर सकते, सिर्फ उसको NAND गेट ही ऑपरेशन परफॉर्म करेगा. AND गेट का नहीं, नॉट गेट का नहीं, और गेट का नहीं, एक्सॉर गेट का नहीं, और मक्स, डीमक्स, रजिस्टर, काउंटर भी यूज नहीं कर सकते उसको. सो इसलिए उसको हम बोलते हैं फिक्स फंक्शन आईसी. सो इफ आई वांट टू कंस्ट्रक्ट दी एनी डिजिटल सर्किटरी, आई हैव टू यूज one dedicated IC for a dedicated function. So what happens because of this, it requires more number of ICs, fixed function ICs, as they are performing their task independently and specific task only, I mean. तो हमें उसके वजह से नंबर ऑफ ICs यूज करने पड़ते हैं ज़्यादा, तो उसका कॉम्प्लेक्सिटी बढ़ जाता है सर्किट का, पावर डिसिपेशन बढ़ जाता है, और कॉस्ट भी बढ़ जाता है, और एरिया एक्यूपेशन भी बढ़ जाता है. सो वो रिप्लेस करना है हमें कि प्रोग्रामेबल लॉजिक डिवाइसेस. सो प्रोग्रामेबल लॉजिक डिवाइसेस में फ्यूजिबल काइंड ऑफ इनपुट्स होते हैं. इसका मतलब है एंड गेट इज प्रोग्रामेबल, सो वहाँ पे एक फ्यूज होते हैं, एंड इफ आई पास हाई करंट थ्रू दोज फ्यूजेस गेट ब्लोन ऑफ, दैट मीन्स डिसकनेक्ट होते हैं. ओके, तो उसका मतलब है कि प्रोग्रामिंग होता है. सो इफ आई टेक ए एग्जांपल ऑफ एंड गेट एंड इट इज हैविंग 4 fuses and A, B, C, D are the inputs and Y is the output, and I want Y is equal to CD only, so I have to blow off the fuse of A input and D input. So at the output of AND gate I'll get Y is equal to CD only. So इसका मतलब भी programming is done. So programmable logic devices का advantage है कि जो हमने ड्रॉबैक्स बताए फिक्स फंक्शन आईसी के, कि उसके कॉस्ट ज़्यादा है, फिर एरिया रिक्वायरमेंट इज मोर, देन पावर डिसिपेशन इज मोर, complexity goes on increasing, and number of ICs also goes on increasing. Also they are not that much secure. So with the help of naked eyes also, if I see the circuitry, one can copy the design also, but in PLD it is not possible. So to overcome all these drawbacks, the PLDs are being developed. So PLDs are basically two types are there, that is the PAL is there and PLA is there, programmable logic array, programmable array logic, and PROM is also there. So ASIC, application specific integrated circuit, it has the last two letters IC, it is integrated circuit, and application specific, it performs only specific function like an embedded system. So if I take an example of a copy vending machine, copy vending machine will not be replaced as a washing machine. So it will perform the specific task only. Embedded things are embedded, and it is performing application specific, only specified application. Then coming to the CPLD and FPGA also. So complex CPLD is a complex PLD, that is complex programmable logic device. So it is nothing but the complex kind of design. One can't go directly for the PLA or PLA, but for the complex kind of things, if the SOP and POS terms are more, then CPLDs are being used. And next one is the FPGA, that is field programmable gate array. So you can FPGAs, many types of FPGAs are there, huge number of, in terms of millions, the gate count is there inside of one FPGA. So as I told you, जैसे मैंने आपको पहले बताया कि फिक्स फंक्शन आईसी के वजह से हमें बहुत सारे ड्रॉबैक्स है. तो FPGA, I'll program FPGA for a washing machine. So the FPGA washing machine जैसा काम करेगा. So means no need to replace the device, no need to replace the main processor. So by changing the programming, one can change the functionality of the device. that is main implementation part device, that is FPGA, and in this way one can change the entire application. So that is the beauty of the FPGA. Then coming to the analog communication to digital communication also, the AM FMs are nowadays are not that much famous, so or one can say not used. So digital electronics is there, digital communication is there, that is it is first is the PCM is there. So in this, analog signals are being sampled, and for each sample some value is being assigned, that is nothing but the quantization. And if some error is there while assigning the digital value to the analog sample, it is called as a quantization error. And those, to remove or overcome those quantization error, there is a facility, that is you can increase the number of samples, you can increase the signal, that is digital signal, in sample signals frequency you can increase, and you can overcome the, that is the quantization error, or one can say quantization noise. So in this way, for each sample, if I want to convert the signal into 8 bits, so each sample is having the 3 bits. 3 bits are there. If 4 means 16 samples are there. So in this way, while transmitting any character or any late number, so values are assigned, that is 0, 1, 0. As an example, if I want to transmit K letter, so it may be a combination of 8 bits, 0, 1, 0, 1, 1, 1, 0, 1, like this. So digitally it is being transmitted from one end to the another end. Okay, so that's all. Thank you.